Hello everyone! Before we start, I would like to tell you all first that wherever you are right now, I hope you are doing well amidst everything that has been going on. It's been a tough new month. Honestly, the fact that you are here and are still trying your best already speaks a lot. So, to ease the weight off your shoulders, we decided to create this video to enlighten you with our chosen pre-calculus topic.
The topic we chose is fairly simple. It is one of the first lessons we have learned in this academic year. It's how to convert a circle's equation from standard form to general form. But before that, let us define first what a circle is.
A circle can be described as the locus of points equidistant from a given point known as the center. According to page 4 of our Quarter 1 Module 1 entitled Illustrating Different Types of Conic Sections, a circle is a special kind of ellipse where the plane is perpendicular to the axis of the cone. A circle has an equation that can be written either in standard or general form. As stated earlier in this video, we will be tackling how to convert a standard equation into general. Here's how to do it.
There are two equations found in the circle, the standard form and the general form. In this vlog, we will be helping you out on how to convert the standard form of a circle to its general form. But before that, we must be familiar with the equations of these forms first. The standard form of a circle is in the form of the equation quantity of x minus h squared plus the quantity of y minus k squared equals r squared, while the general form of a circle has an equation ax squared plus ay squared plus cx plus dy plus e equals 0, wherein a is not equal to 0. As an example, let's use the equation the quantity of x minus 3/2 squared plus the quantity of y minus 3 squared equal to 29/4. The first thing we need to do is to apply the exponents. In this part, we turn the square of a binomial in the equation into a perfect square trinomial. So, the quantity of x minus 3/2 squared becomes x squared minus 3x plus 9/4, and the quantity of y minus 3 squared becomes y squared minus 6y plus 9. Our equation now turns into x squared minus 3x plus 9/4 plus y squared minus 6y plus 9 equal to 29/4. To equate the equation to 0, we must transfer 29/4 into the left side of the equation. That makes our new equation into x squared minus 3x plus 9/4 plus y squared minus 6y plus 9 minus 29/4 equal to 0. We then combine like terms. The new equation is x squared minus 3x plus y squared minus 6y plus 4 equal to 0. Lastly, we arrange the terms in the form of ax squared plus ay squared plus cx plus dy plus e equal to 0, which makes our final equation x squared plus y squared minus 3x minus 6y plus 4 equal to 0. Note, to recheck if the final equation is correct, we must convert the equation again from general form to standard form. But that's another lesson for you to learn.
And that is it! We sincerely hope that you understood the process, and if you want to see more examples, we will leave a link to them down below.
Thanks for bearing with us today. Mathematics is an endless opportunity for us to continue and expand our learning.
If you like this video, please be sure to give it a big thumbs up. If you want to see more pre-calculus content, then don't forget to subscribe. And you can hit that bell button if you want to be notified for our next tutorial.
Thank you so much for watching. We hope to see you again soon in the next video.